Hi guys. So this week we're finishing up the unit on functions, and there's one little thing that we're going to add. So I did kind of want to go back over some stuff from the beginning of the unit. So one thing is just making sure we remember how to solve equations. So with solving, I always recommend drawing a line down the equal sign because you want to keep both sides of the equation balanced by only ever doing the same thing once on both sides. Another way that this is helpful is that a lot of times you have to, excuse me, a lot of times you have to simplify before you can start solving. And this helps me know if I need to simplify because I need to make sure there's only one variable, one number, and I need to get rid of all my parentheses. So the first thing I want to do here is distribute. So this 7, I want to multiply it by everything in the parentheses after it. So I'm going to bring down my -4. And 7 times b is going to give me 7b, and then 7 times 8 is 56. The other side I'm just going to bring down. Then on the left, I do have like terms. So before I start solving, I want to combine those, because if you start solving now, it's going to get confusing because you can have numbers left over. Sometimes people try and do it in 3 spaces, and then it's not balanced. It's like a whole thing. So just be careful that you always simplify completely before you solve. So now that I've simplified, both sides are as simple as they can get. I want to get all the variables on the same side. It does not matter which side that you move things to, you'll end up with the same answer either way. But just out of habit, I'm going to move them to the left. So I'm going to subtract 5b on both sides. So 7b minus 5b is 2b. Bring down my plus 52 and my 38. Now that I have b by like only one, sorry, now that I have only one b, I need to get it by itself. So I need to start getting rid of the numbers around it. And generally start with what's furthest away. So I'm going to subtract 52 on both sides. So I'll bring down my 2b, and that'll be -14. Sorry, I had to think. Okay, so last thing, 2b means 2 times b, so to do the opposite, to get rid of that 2, I'm going to divide by 2, and I will get b equals -7. Ta-da. Awesome. Okay, so the other thing we went over before we really got into functions was linear equations, so I just want to make sure that we're good on some of the skills we picked up there. So writing an equation in slope-intercept form. If you're given a graph, slope-intercept form is y equals mx plus b, where m is the slope and b is your y-intercept. So for my graph, I need to find my slope and my y-intercept. Y-intercept is the easiest thing to find. It's just where it touches the y. So b is -2. The slope, I need to find another point where it touches at the corner of a box, which is the only other point on this graph is going to be right here. And then I'm going to find my rise over run. So if I'm going, from this point, I go down 1, 2, 3, 1, 2, 3, 4. So I went down, so that's -4. And then I go right 1, 2, 3, 4, 5. So my slope is -4/5. If you get confused on positive or negative slopes, just remember that if the line is going down from left to right, it's a negative slope, and if it's going up from left to right, it's a positive slope. So my actual equation, I just plug in m and b. -4/5 doesn't simplify, so it's going to stay -4/5 x, and then -2. When I'm given an equation in standard form, what I need to do is actually solve for y. So I'm going to draw a line down the middle because I'm actually going to solve. And it's always the same two steps from standard to slope intercept. So I'm going to subtract 4x on both sides. Now be careful because remember that these two terms, the 7 and the negative 4x, they're not like terms. They don't actually combine together because one has an x and one doesn't. So I'm just going to basically bring everything down. The 7y comes down, the negative 4x comes down, and then the 7 comes down. So then I have to get rid of the 7 in front of the y, and I do that by dividing. But I have to do that to everything in my equation. Okay, so those cancel, and I will get y equals negative 4 over 7x because 4 and 7 don't divide evenly. And then 7 divided by 7 is just 1. And once you have y by itself, you have slope-intercept form. So that was just some review stuff. Like I said, this week we're going to kind of just add in the last little bit. So if you remember, we've talked about domain and range. Domain is going to be basically all of your x's or inputs. It's a way to describe what the x's or inputs are for a graph. Range is the y's or the outputs. Sorry, that end doesn't look like an inputs. We've talked about intercepts. So an x-intercept is where it touches the x-axis, or when y equals 0. And y-intercept is where it touches the y-axis, or when x equals 0, depending on if you're looking at a graph or an equation. The new stuff this week is going to be maxes or mins. So a maximum is basically a point where a graph is going to change it goes from increasing to decreasing. So I'm abbreviating, but increasing to decreasing. Basically, it's the top of a hill, sort of. Like you have, like, think of it, anytime there's a hill and there's something at the top, that would be maximum. For a minimum, it's a point that changes from decreasing to increasing. So it's decreasing and then it starts to increase. And it's basically the bottom of like a U or like a V or something. It's like a lowest point, but it doesn't have to be the lowest point on the whole graph. It just has to be at the bottom of somewhere where it changes direction. So the big thing about maxes and mins is that it's where it changes directions. Okay. Cool. So that's vocab. So I will just jump right into it. So first, looking at domain and range of this. Now remember, for domain, we're looking left to right. Are there any boundaries? And in this case, I have an arrow on the left and an arrow on the right. So there's no boundaries left or right. So my domain is going to be all real numbers. For range, we're looking high to low. So the lowest it goes is 100. Everything else is above that. So range is y, my boundary is at 100, and everything's above that, so I'm going to say greater than or equal to. As far as x-intercepts, that's going to be anywhere that it touches the x-axis. So there's several of them, okay? And remember, these are points, so you want to write them as points. The points are written xy, so I have negative 5, 0. I have negative 2, 0. 2, 0, and 5, 0. For y-intercept, okay, it's where it touches the y-axis, and these, 1, 2, 3, 4, 10. If you actually count the lines, it's actually right at 100, because the lines go by tens on the y. So the point is going to be 0, 100. So as far as maxes or mins, a maximum is, a maximum is going to be anywhere where it's like a highest point, the top of the hill. You're looking for hills. So in this case, my y-intercept is a maximum. So a maximum is a point again. So it's the point 0, 100. As far as minimums, I have two. If you'll notice, there's 2 points where it is the bottom of a U, right? Where it changes direction. So let's see, I'm gonna try and figure out what. I think that's at 4, -4. So my minimum is going to be the point 4, -100. And if I did I say 4? -4, -100, and 4, -100. Last thing is function notation. So if you remember, function notation is where you have to be able to tell are they giving you an X or Y. So if they give you a number inside the x-axis, that makes sense. They give you a number inside parentheses, they're giving you an X. So I go where X is 3, and I'm going to draw a line straight down and go over, and that is at 60. If they give me a number that is not in parentheses, it's what it equals. That's the Y. And they're asking you what X is. So I have to go anywhere that X is 50. So I'm going to draw a line straight across where X is 50. There we go. And every time it touches, I'm going to go up. So, oh wait, I did -50. Ugh, and that should have been -60. Forgive me. 50's up here. 50. Okay. So this one, it's about a 1.5, at about -1.5. And especially when it's decimals, like don't freak out too much if you're a little bit off. It's not gonna be quite at 5. Let's just say 5.1 and -5.1. Obviously, there's gonna be a little objectivity when it comes to decimals, which can't. Okay. Anyway, my graph looks a little crazy. But as the only new stuff really was the maxes and mins. Everything else we have talked about before. We haven't done x-intercepts and y-intercepts on these kind of graphs, but we have talked about them. So here's another one. This one, as far as domain and range, sorry, lost my train of thought. It does not have arrows, so there's 2 boundaries on either side. There's a boundary to the left and a boundary to the right. So when that happens, that's when we use the compound inequalities. And the furthest left it goes is -4, and the furthest right it goes is +3. Range is going to be the same thing. The lowest to highest with a compound inequality with a y. So the lowest it goes is -1, and the highest it goes is 3. Next thing is intercepts. So that's going to be where it touches each axis. So for x-intercepts, it touches twice at the points 1, 0 and -1, 0. For y-intercept, it touches once at the point 0, -1. And then we're going to be looking for maxes and mins. So as far as maximums go, I'm looking for any point where it changes direction, where it was going up or where it was going down. So it's kind of like thinking of the top of a hill, but if you'll notice in this one, it's not like a curvy hill, it's a pointy hill, sort of. So I have a maximum here at the point -2, 3, and at this point 1, 0. I have a minimum here where it changes direction going from down to up at the point 0, -1. Okay. Last is function notation. So they give me the x when it's in parentheses, so I go where x is -3 and see what my y is, which in this case it is 2. And for the second one, we'll find x when f of x equals -1. They've given me y. And I want to see, so I want to draw a line all the way across when y is 1. So I make sure I get all the points, because remember, a lot of times these have more than 1. So y is 1 when x is -4, and also when x is, that would be, let's just say about -1.35 or 1.4 or something like that. -1.35. Again, with decimals, obviously it's not going to be easy to know exactly what it is unless you have a better graph. So just general ideas are good. Cool. I got one more. So again, with domain, we're looking if there's left or right boundary. And if you'll notice, there are arrows in both directions. So my domain is all real numbers. For range, the lowest it goes is -3. And if you'll notice, these arrows, they don't point up at all, right? So there actually is an upper boundary. It stops going up at this point. So my range is going to be a compound inequality because all the points are between two boundaries, and it's from -3 to 1. Okay. Intercepts. So x-intercepts are where it touches the x-axis. So I've got one at 2.50 and at 70. For y-intercepts, it's where it touches the y-axis, which happens at the point 0, 1. So for maximums, because there are no hills where it's like there's a very tip-top point, we don't have any specific maximum points. So when that happens, I'm just gonna say, none, or an A, or whatever. And then for minimums, I do have a minimum here where it's the bottom of like a V. It changes direction at the point for -3. Last thing is the function notation. So if they give me a point in parentheses, that's my x. So I go where x is 5, and I want to see what my y is. So in this case, it's -2. In this one, they gave me y, so I go where y is -1. And I'm going to draw a line all the way across the graph because I want to get every x. In this case, there's 2 x's where it's y is -1. So it's when x is 6 and when x is 3. Okay, so that's everything for this week. Please show up to the live meet where I can check and make sure y'all kind of understand what's going on. And make sure you get your homework turned in, and any past work that you haven't been able to finish, make sure you get it turned in this week because this is the 6th week. So, we're closing in on the end of the 6 weeks, and parent-teacher conferences are next Monday. So you want to make sure that you got a good grade in before I start talking to all your parents. Anyway, hope you guys have a great week.